Hey, it's Steven from Legit Tutorials and the Green Engineers, and welcome back to my water jet series. Super tired right now, so bear with me. As it is 11:30, just like usual, but a lot of stuff going on today. Um, I was able to talk to the water jet suppliers, and I did find one that looks like it is pretty good. I'm going to show you which one that is. Library, bookmarks. Not downloads, bookmarks. Bookmarks. These guys. These guys, I think I'm going to look more into these guys as they have the flexible. Oh, so here, right here. So standard length provided is 10 feet. So that's perfect for our application. I think that's gonna, and they have up to 31 or 40,000 psi. So 30,000 standards are available. 31 250, right? And rated pressure, standard length 10 feet. Different custom lengths available, but versus 10 feet is 2.5 times rated burst pressure, working pressure. So basically, I think that these guys are the best situation. So pretty much what I'm looking for is they recommend not using NPT because I guess they say that it's very hard to rate mechanically. So basically, what they do is they basically derate the hosing. So what I'm going to look for is I'm going to look for what two fittings we need to ask these guys for the so we're going to do that, and we're also going to do the CAD to make sure that 10 feet will work, and if 10 feet is too long, how long do we actually need. So basically I'm going to look here in my email here about the fittings. So one is AccuStream. Let me see which one it is. Okay, so right here. So thank you for your call today. The thread on the inlet side of our A2 cutting head is a 7/8 14. Okay, male and female. So it's a 7/8. That's a big guy. Interesting. So yeah, so let's go ahead and forward this to myself. Forward this to the right email. So this is the cutting head by AccuStream. So let's go ahead and send that to myself. 7/8 14 fine thread. Okay, so now let's see if we can find the Julier brand. Okay, so here is when I bought it. So I bought it all the way back in... When did I buy it? 2018, 7/25. So it was exactly a year and 5 days ago. Okay, so here is the so the inlet is an M14 1.5. That is the outlet. And I need pressure fitting. I was trying to find a supplier for it. Okay, so let's look in here for fitting. And here is the pump type. It's a JLGD 400. Oh, that was me sending an email to myself. Okay, so nothing comes up when I look up that email. I look up that. And so again, here's my pump. Right, this was the pictures the manufacturer did. It says he attached pictures, but I do not see it. He does have his contact information there. So, but yeah, we don't know what. Okay, so let's go ahead and make another message to myself. The Green Engineers. So inlet and outlet to pump. Fitting. So it's basically M14 1.5. So now that we've done that, now we can send an email to these guys. And his name was Tim Kane. Tim Kane was the guy. Kane about our conversation yesterday about high pressure tubing. I found out my inlet and outlet fittings, so I need 10 feet of hose and a inlet of type. Okay, so let's go with that one. That's stuck. So inlet or 1.5. But then again, this could be anything. So basically the M14 1.5, which is the outlet of the pump and the inlet to the pump, I could attach anything to that size, because basically I need to make a manifold where I connect the two outputs together. So, and inlet to head is 7/8 by 14 UNF. So basically, whatever works best as for the hosing, we could use that as an inlet. Again, I would like the smallest OD as to make it more flexible by having a lower minimum bend radius. My operating pressure is 30K. Medium is water. How much would something like this cost? I will talk to you further about this tomorrow. Let's see, do they have... I think you said info. Okay, so basically that is good. Let's send it. Okay, so I'm going to talk to him tomorrow morning about 7/8 by 14 UNF inlet and a whatever to go into my housing, and then whatever for my whatever works best for him for the manifold, and then the manifold. So that will be, once we finalize this, that'll be the last thing that we need to do is the manifold. So we have how we're going to actuate the pressure, and the pressure is just going to use a basic pump. I mean basic. Just a 60 psi capable a hose for a regular compressor, so nothing crazy there, and then just quick disconnects, and then just have quick disconnects thread onto that these brass guys here. So just have quick disconnects, and then have it go from one to the other. And then we need this rigid hose, this flexible hose, 10 feet to the manifold, and we need to make these two manifolds, and then that's pretty. Oh yeah, and then we need to make the. So if we go here, I was working on Shredder, so let's go ahead and go back let's look at the then we need to make this guy. We need to make the sheet metal housing around it, and then we need to make the slats that go in there, or just some sort of plastic thing that goes on top. Probably just going to be a plastic piece that goes on top. So just like I showed you in that one video where he had the what's it called? He had the that DIY one using a pressure hose. It just had a plastic grate in here. So that's what I'm thinking, and just take that and then make some legs on it, and so the legs drop down, and be really, really tight on the plastic, and then run these parts. And then obviously it's going to cut the plastic. It's not going to be that bad. We'll have to see. And then so that will be probably temporary, and then the next thing would be to have something that hangs on this side here, and then drops down, and have it, and maybe even, well, you can't water cut it. Well, you could water cut it sideways. So I could load one in, water cut it, load another one in, water cut it. And so basically it would have like probably a hook, and then it will drop down into the tank, and then it'll have another slot in it, and then we could put another piece on there. And probably just like 1/8 of an inch or smaller piece of steel sitting in water, probably a piece of aluminum or something. Aluminum expensive, so maybe just steel. I'll just paint it. It's not really that big of an issue. Alright, so let's go back here and let's see what it would look like if we had a pump. And so obviously we're pump with 10 feet hose, so obviously we're out of room here on the back, so we could only put it here or here. So let's just say that it was, let's just say it was over here somewhere. Oh, I accidentally. Oh, look at that. Okay, so actually we don't want to do that. So let's do plane, not offset plane. Let's do plane between two planes. Mid plane. Planes, boom. And boom. Okay, so now we have it in the middle here. And so let's go to the front. And let's say that our pump is... So let's unhighlight that. So let's say our pump is here. And again, basically this guy has to be within 48 inches. Oops. But I believe this pump is pretty skinny, so I think it's definitely not that tall. So let's change this. "16 inches. Let's see, it's about 12, not including the handle and stuff. And then for the width, let's see, yeah, about 7 inches. That sounds about right. And then this is going to have to be here and here, so halfway between these 2 points. So basically, oh, and then I want this to be in line. With the floor. What is this line? Okay, so then we want half over here, half over there for the hose. Well, the hose doesn't need that much room. So let's just say this, and then this, and then 48 inches. That should be fine right there. 4 inches, yeah, I think we'd be, well, the nipple thing sticks out, so probably what we're gonna do is turn the pump sideways. So basically it's gonna be probably over here at the end. So it's gonna be this way, pump's gonna be this way. And then the hose can come up and around. But let's just see. So let's just say that the hose in actuality is coming from here, let's say. And let's say worst case scenario, so let's say arc. Let's say from, it's about here or so. From here till here. You get the idea, sort of. Or another thing is we could do a 2-point circle. Yeah, that's a good idea. 2-point circle. How am I actually going to model this? It's very interesting. Okay. Because in actuality, basically how I would do this is I would limit it to whatever arc that you could possibly do with the hose. But I do not have that. So let's see. I have my piece of paper here. Ooh, so that's a foot right there. 12 inch. That's 9 inch. Let's say 9.5. Plus, let's say 13.75 plus 23. So let's just say that's not, that one was 975, that other one, so that's 23.5 plus 12 plus 23.75. So, 75 and there's 75. Let's just say that you add those together and it's 10. So 24 plus 23, 747 plus 12 is equal to 59. 59 is almost 5 feet. So I think we would be pushing it with 6 feet. So I think 10 feet should be pretty good. And if we put the CNC machine, the mill, on top, and basically we would hang this hose with some sort of spring something, and it would just kind of dangle, and it would help it support it moving around. So basically it would come from over here, but again, remember, we want a big enough arc that it goes around and comes down. But again, this thing is already, it's already about 30 inches tall. It's almost 3 feet tall already. Oh man, I got, how many tape measures do I have in here? How much did it say? .28 inches tall. Oops. So 28 inches tall. Let's say we clear it by 3 feet. That's 36 inches. So another 8 inches above. So I think that 10 feet might be exactly what we need. So that's basically double what we see right there. So we're going to have more of an arc as it goes up there. And probably the pump is going to be sort of sideways, because again, we don't have really the clearance as much. And this hose is going to come up and go down into the part, and then it's going to be on the floor probably with some sort of box built around the hose so that it kind of muffles the pump, and then maybe eventually build a box around the compressor to quiet the compressor down. But again, eventually I want to have a actual direct drive pump to increase the efficiency for power, and also the control for power, the heat generation so it doesn't get so hot, and more power, so higher pressure. Because again, like you saw, this hose is rated at like 2.5 times burst. So you're talking what, 70 times 50 plus 15, that's 85 psi, 85,000. And even industrial grade, big guys don't go that high. So I think 10 feet, we should be able to work with 10 feet. 6 feet is going to be pushing it. Another 4 feet might be a little on the increased side. But again, you can see these angles here. So if this is like I think some of the other ones were like 5-inch bend radius. Let's see, I have some of that stuff. 2M high pressure stuff. Parker. So this is my cat freaking petting my back. Okay, so minimum beta radius. So I'm gonna say 100 to 100 millimeters. It's gonna be somewhere between 100 inches. It's gonna be somewhere between 100 millimeters, which is 4 inches, and 150 millimeters, which is 6 inches. So right? So basically this guy has to be, if you look at it, bend radius, so the diameter is actually 12 inches. So basically that is the maximum that you can make it do, right? So pretty much what you could do is you could do a whole bunch of these guys and then kind of see what you could do. So I think 10 feet should definitely work. Shorter, 6 feet now I'm thinking is not going to work. Probably more like 7.5 or up to 10. But again, I could get rid of that by lifting this guy up, which again, I'm probably going to put rubber because this thing's going to get really loud shaking on the concrete. So put some sort of cork or something underneath, a whole bunch of cork, lift it up off the ground, and then set it in there. And then have the hosing go up and in. And then on this side again, have my controls, the exhaust valve, the blow-off valve, which again I need to muffle, and then the air-driven valve, the brass valve with 12 volt. And again, we could have those bolts driven off the same relay, and only need to use one pin to actuate both the exhaust, etc. So now this looks good. So we're gonna see what kind of price we're looking at for this hosing tomorrow morning, and then after that we need to eventually. I might grab the pump on the way back home. My calipers are not working right now, so it might have to be a rough visualization with the with just a pair of tape measure, with just a tape measure measuring it to figure that out, and then figure out where we could get that done, and then that will be pretty much it. And how we're going to get those fittings on there, yeah. So that's kind of basically what I need to do, and we're gonna get that done tomorrow. And I should go get my pump and bring it back, and have my pump and my cutting head available so we can finish this design, and then figure out where we need to go. And then once I finish the design, then I could put it back in the storage. Okay, so this has been Steven from Legit Tech Tutorials and the Green Engineers. Thank you guys for watching this water jet video number 12. I will see you guys in the next video. Take it easy. Peace.